So, welcome to the second part of the tutorial on DOC estimation. In the first part, we have described the basic procedure for calculating the DOC, the various terms involved, and we completed the calculation of one important part, which is the standing charges. Moving ahead, let us look at the estimation of the cost for other components, starting with the crew cost. Now, the crew cost has two major components, the cost towards the cockpit crew, and we know that for an 8-hour flight we need 2 people in the passenger in the cockpit of the aircraft, and if it is more than 8 hours then we need another set of crew, but ours is a short haul operation, so we will never have a requirement for more than 2. Now, what is paid to the pilots? There is an annual salary, there are flight allowances, right? Both of them have to be considered. Then there are cabin crew members. These are the members, the flight pursuers, the air hostesses who serve the passengers and look after their safety. So, these as per the norms for short haul operations, you can assume that one crew member is enough for serving 35 passengers. So, in our case our aircraft is just 19-seater. So, definitely only one crew member is required in the cabin. Now, we do not get into the nitty-gritty of calculating the cockpit crew cost separately and cabin crew cost separately. We just say that okay, let us assume that the cost towards the cockpit crew is 20% of the cost towards, the cost towards the cabin crew is 20% of the cost towards the cockpit crew. So, we just multiply the cockpit crew cost by 1.2 and you get the total crew cost. It is an assumption, okay. One can do more refined sizing calculations for cockpit crew cost and cabin crew cost, but in my case I have just taken it as 20%. So, let us go ahead and calculate. Now, the crew cost is going to be a function of the block hours and the charges. Now, as I mentioned, the salary or the earnings of the cockpit crew members varies from place to place and depending on various situations. We have assumed that the net number will be $100 per flight hour, and you will have one member in the cabin for 35 passengers. So, here NFA, number of flight attendants, will be equal to 1, and therefore, the crew cost will be the block hours 1.503 block time into the US dollar per flight hour, and you have 2 in the cockpit and you have 1 in the cabin, and the cost of the one in the cabin is only 0.2. So, please calculate the value of the crew cost with this formula. It comes out to be $330.61 per trip. Moving ahead, let us look at the maintenance cost. Now, this is going to be little tricky. It is tricky because the method I have used to calculate the maintenance cost is by scaling up the costs which are related to Dash 8-300 aircraft in 1996. I was fortunate to get some data about this aircraft's maintenance cost from some document which the company had circulated. So, based on that document I said, oh, now I know how the maintenance cost of Dash 800 can be estimated. So, I thought why not use the same method for other aircraft, but appropriately scaling up the costs. So, I will show you what method I have followed. But first we need to understand what are the components of the typical maintenance cost. So, broadly speaking, we can categorize as aircraft maintenance, and here there are some expenses per flight hour, some expenses per trip and some expenses per annum. Similarly, the expenses can be towards material or towards labor, because when we maintain the aircraft we have to change some parts, so there is a material cost, and to change the parts we need trained and skilled manpower, maybe you can licensed manpower, so therefore there is some labor charges per man hour rate. Similarly, you have the engine maintenance, there again you have some expenses which are per flight hour, some expenses which are per trip and some expenses which are per annum. Okay. So, for example, there may be a requirement to change the tire after so many trips. So, let us say after n trips you have to change the tires cost so much. So, therefore, you have to divide the total cost of the tires divided by that n, you will get the cost per trip, just an example. Okay. Here also you have cost towards material and labor. So, we are going to get all these components, material and labor, per hour, per trip, per annum for both airframe and engine, and use it for our estimation. In the engines, there is an additional cost of overhaul cost, because the engine has to be sent to the OEM for overhaul regularly. There are certain things that the maintenance engineers from the airline can do, but there are certain things which have to be done only by the OEM. The same thing is true also for an airframe, but it comes after many years or many hours of operation. So, we do not really consider that in much detail here. Now, to get the numbers scaled up from 1996 to the year 2025, we need to look at two indices. One is the Employment Cost Index, ECI, which tells us how the cost per man hour or man hour rate for aviation is increasing, for aviation maintenance. So, what I have done is I have looked at the maintenance man hour rates for maintenance assumed to follow ECI of the aircraft maintenance industry. So, the ECI value, if you notice, in the year 1996 is approximately 80, and the same value in 2025 is 173.66, which means that the cost of manpower have more than doubled from 96 to 2025. The exact number is 2.170. Therefore, if something costed $10 in 1996, it will cost 2.17 into 10, $21.7 in 2025. Okay. So, all the costs related to the manpower will be multiplied by 2.17. Similarly, if you look at the PPI, okay, the PPI is the producer price index of manufacturing industry, because certain costs are for the materials and those costs will come from the cost of the material. So, the PPI index in 1996 was 125.8, and that index has grown to 248.7 in 2025. So, therefore, if we assume that the aircraft components which are used for maintenance, they assume to follow the PPI of the aircraft maintenance industry, you get a cost escalation factor for PPI, which is 1.977, broadly double. So, the manpower costs have increased more, 2.17, whereas the material or the component costs have increased only by almost double, 1.977 to be precise. So, now what we did is, this is a little bit involved formula, so I am going to go very slow and explain to you. So, here you can notice you have airframe mass and then there are various components. Now, for Dornier 228-212, the airframe mass is 6200 kg, but the one for Dash 8-300 is 10124. Okay. So, we assume here that the airframe maintenance costs are going to scale up or scale down on the basis of root of the airframe weight. Again, an assumption. It is reasonable, it is based on industry practice, but it is an assumption. Something has to be assumed, so we assume it. In this particular expression, there are many factors. FAMPT is the cost of airframe material for maintenance per trip. So, every trip that you incur, some amount of money is required for the material that is utilized. This could also be oil, it could be other item. Anything that you have to buy and use and replace or change per trip, okay, or over a few trips is FAMPT. Then to do this work, you require some time, some man hours. So, FALPT is airframe labor per trip, that is the man hours per trip required for doing airframe maintenance. So, FALPT will be multiplied by man hour rate to get the cost of the labor, and the FAMPT is the cost of the material. So, per trip costs per trip costs of material and labor are the first terms. Then you have certain costs which are incurred as a function not of the trip, but of the trip of block hour. Okay. So, where FAMPFH is the cost of material for airframe maintenance per flight hour. Depending on how many hours you fly, certain materials have to be replaced and there is a cost for that. So, this will have to be multiplied by T block to get the cost per trip. And also to do this work, also you require manpower. That manpower also is going to have some man-hour rate. So, the number of hours required to do this work multiplied by the man-hour rate of the labor plus the cost of material. If you add this and multiply with the block hour, you will get the costs per block hour, cost per trip, and together you will get the cost per trip. Okay. It is a bit involved, but you will be able to clarify it when you do the step by step calculation. Now, similar thing is for the engine. For the engine it is little bit more complicated because here there are additional components like there is some money to be kept aside for overall. Now, here what we do is we look at the shaft horsepower in takeoff. For Dash 8 300 is 2380 per engine, whereas for our aircraft it is 715, right. So, FEMPT is analogous to the previous one, cost of material for engine maintenance per trip, right. But then you have man hour per trip for engine maintenance and there is a man hour per trip for engine overall. So, this is different now because overall is happening at the OEM. So, FMHR is the man hour rate for engine manufacture. Then we have FEMPFH, which is the cost of material for maintenance per flight hour. So, the terms which are inside the right bracket, the terms which are here, okay, these terms are multiplied by block hour because these are dependent per block hour, okay, and these other terms are a function of only the trip. So, each trip consists of so many block hours. So, therefore, the costs which are block hour related are multiplied by T block and added there, right. Now, this is how we do the scaling. So, I have already shown to you that the cost escalation ratio for man-hour per hour is 2.17 and the cost escalation ratio for material cost is 1.977. So, this table shows the value of various parameters as quoted for Dash 8 300 in 1996, and then we are multiplying with the corresponding cost escalation factor, and then whichever item in this is manpower related, only the first one, the man hour rate, there we multiply. So, what it means is, okay, it means that in 1996 the man hour rate was 18.80, but this number has gone up by 2.170 and now the man hour rate is 40.80. Okay. So, today when we do the maintenance, we will need $40.80 per man hour for airframe. Similarly, you have got the cost of material. So, material cost for airframe maintenance was 21.49, but then this number has to be scaled up by 1.977 to get 42. Like that. So, all these numbers have come. Notice the largest value is for the engine overall per flight hour. The material cost was $74.69. So, per flight hour there are certain after so many flight hours you need to do overall. So, if you divide it per flight hour, it becomes to $74.69 way back in 1996, and that number today becomes 147.66 because we have a cost escalation of 1.977. So, these numbers will be used in the calculations now. So, again the formula for maintenance is repeated, and now we are inserting the numbers which are applicable to our aircraft. I won't like to read all of them out. You can actually pause the video and have a look at these numbers, and therefore, if you calculate the value, you can see one by one these numbers are coming, and then you have the formula. So, 3178 is the airframe weight of Dornier 228 as against 10124 for Saab 8300. We take a root of that to get the cost scaling, and then we put all the numbers inside which are already explained to you. I'll pause here, and I'd like you to also pause and do this calculation and tell me what number you get. The number comes out to be $103.72. So, therefore, $103.72 per hour per trip is spent in airframe maintenance for operating this aircraft. Let us look at the engine maintenance cost. I already showed you the formula earlier and I already told you, but now we are entering the numbers here. So, all the numbers are going to be entered here one by one, right. So, this is you can actually just take a picture of this page and keep it with you, because you will be requiring to enter this number, but do not worry, I will help you because I have already done that for you. So, this is the formula, and again we are giving the numbers here, and on the bottom we have that full equation. I want you to take a pause, and this will be a very long pause because you will have to do very detailed calculation. Calculate what is the cost of the engine maintenance. It turns out to be 168.80. So, this is the cost of engine maintenance, right. Now, we go ahead. The maintenance cost is basically nothing but summation of the cost towards aircraft, airframe, and cost towards the engine. So, we just add these two numbers together and take a pause here, calculate this number and tell me what is the total cost. The maintenance cost turns out to be 272.52. Now, we estimate the fuel costs. Fuel costs, as I mentioned, are taken for operation in Mumbai for October 2025 as quoted by the Indian Oil Corporation for aero turbine fuels. So, for this I looked at the data. Now, the cost of ATF varies from city to city in India. The same company is supplying fuel at different rates. I took the average of these four and I got the average as 93.9 rupees per liter, right. Now, the density of this particular fuel as per the data available on their website is 0.84 kilograms per liter. So, therefore, the block fuel, the amount of fuel that you will require in operating this, already we have done the calculation, but I will again leave it here. This is 345.1 kg. Now, 345.1 kg of fuel basically means divide by 0.84 to get the value in liters, multiply by 93.8 to get the values of cost, and divide by 88 to convert the cost of rupees into the US dollar. So, the cost of the fuel in US dollar per trip is estimated by this formula. Please take a pause here, calculate this number and tell me the value. The value I got is 438.38, largest component so far, I think, apart from standing charges. So, such a large amount of money has to be spent in fuel. And lastly, we look at the airport charges or the charges towards RNFC, TNLC and PHC. Now, what is meant by all these charges? RNFC stands for Route Navigation Facility Charges. This is a function of the distance travelled in the flight information region and size of the aircraft. The terminal navigation and landing charges are TNLC. They are also a function of the aircraft weight, and then for every passenger who transits through the airport, there could be a passenger handling charge, which is normally called as user development fee and security fee. Right now we are not assuming this number in India for our calculation. Generally it is a function of the maximum capacity of the aircraft. Okay. So, my understanding is that these charges are already included in the TNFC in India for small aircraft operating on domestic routes. But RNFC, there is a formula which is a product of a concession factor C into the range factor, into the D factor, the distance factor and to the weight. So, what is the concession factor? If you operate a very small aircraft such as Dornier 228, you have to pay only 20% of the charges. If you operate between 10,000 and 20,000, you have to get a concession and you only pay 40%. but if your aircraft is more than 20,000 kg, you have to pay the full charges. So, the value of C will be 0.2, 0.4 or 1 depending on the weight. Then R is the rate. This is a number which is given as rupees 4949 from 2025 onwards till in the future, till the new rules are announced. The rate is going to be 4949 for domestic aircraft operating. Now 12% will be the GST on that. So, therefore, the rate is rupees 5543 for operation from domestic airports. The distance factor is basically L stage in nautical miles about 100. So, in our case the stage length is 250, therefore, it is 2.5, and finally, we have the weight factor, which is the root of max takeoff weight upon 50,000, where MTO is the max takeoff weight in kg. For us it is 6200 kg. So, when we apply this number to our case, our C factor is 0.2 because the weight is below 10,000 kg. The rate is 5543 upon 88 to convert it into dollars. What is the number? The number is $63. Then we have distance factor. So, here L stage by 100 is 250 by 100 or 2.5, and the weight factor is max takeoff weight of 6200 by 50,000 under root 0.3521. So, for us the RNFC is going to be 0.2 into 2.5 into 0.3521 into 63. This is in US dollars. Please calculate that number. As per my estimates, it comes out to be 11.09 US dollars. So, then we go to the TNLC, the Terminal Navigation and Landing Charges. There is a fixed rate of 110 rupees per ton for small aircraft, and 12% on that is the GST. So, therefore, it will be 127.51 divided by 88. This 127.51 is actually 1.12 into 110, 88 is taking care in dollars, and 6200 upon 1000. So, it comes to be 8.68 US dollars. Now, in India, I do not see a separate mention of Pakistan. So, I am assuming that we do not have anything additional. Okay, right. So, now if you look at the airport cost estimation, it will be the sum of all the three. So, it will be 11.09 plus 8.68 plus 0. How much will that be? Can you please calculate? That number will come to 19.77 US dollars. In other words, if we calculate the DOC now, the sum of all the costs, it will be 450.84 is for the standing charges, which is the highest component. The next component is the fuel, 438.38. The next component is the crew, 330.61. Next one is the maintenance, 272.52, and the last one is the airport charges, which is 19.77. Now, in this case, we have very low airport charges compared to all the others, because the government is encouraging operation of small aircraft at domestic airports. So, it is giving concessions, but if you operate larger aircraft, you may not have such a stark difference. So, please pause and calculate the value. The number is $1,512.18. This is the DOC per trip. Now, we have 19 passengers, we assume they go full, and we are travelling 250 nautical miles. So, therefore, what is going to be the DOC per passenger per nautical mile? It will be 1512.18 divided by 19 into 250. Please pause your video, do the calculation. The number comes out to be 0.3185 or 31.85 cents. This number turns out to be 28.03 rupees per seat per passenger. So, as per my estimate and as per my procedure, the cost per seat per passenger for the airline operating Dornier 228 on a route which is 250 nautical miles with 19 passengers all full is approximately 28.03. The largest component is standing charges, because the cost of the aircraft is coming out to be almost $7.2 million, which is a very large amount of money. Here is a breakup of DOC. We noticed that standing charges and fuel are of the order of $450, crew $330, maintenance 270 and airport of the order of 20. This is the breakup. We see that 30% are standing charges, 29% is the fuel, and then you have crew, maintenance, and only 1% of the charges are the airport charges. This is a typical breakdown of DOC. The largest components tend to be the ownership costs and the fuel costs and the pilots. Okay. This is typically the scenario. Now, if you want to reduce this, you could actually go for, instead of paying 30% standing charges, you could lease the aircraft. If you lease the aircraft, of course, the ownership is not yours, but you are using it on lease and you have to only take care of the regular lease payment. There is no need to upfront invest large amount of money or take a loan. So, the standing charges will drastically reduce. Okay. Plus, generally when you lease aircraft, you lease newer aircraft, so they will have better fuel consumption and they will be also hitting the bottom line very well. So, I hope you have received a broad understanding of the various components of DOC, what factors affect the DOC, and what is the breakup of a DOC for a short haul operation of a commuter and regional aircraft using twin turboprop engines operating a distance of 250 nautical miles in domestic airports in India. Now, just a note before we close, this DOC method is just a theoretical method created by me for my own research purposes, where I wanted to capture the effect of various parameters onto the operating cost. You need not assume this to be the only method. There are other methods available, but I thought this method is enough to clarify to you what are the various components. Thank you so much for your attention.